Now let's look at how we can use Nullclines. How we can use Nullclines to draw the direction field. So first of all, we are just looking at the set of points at which the derivative is good. So remember, our equation is equal to fxy. So you are saying if the derivative has to be 0. So basically, you're looking for all the points where f of x, y should be equal to 0. All the points where f of x, y is equal to 0. And at these points, the derivative is 0. The derivative is 0, then the linear elements should be horizontal. At every point where the derivative is equal to 0, then the linear elements or the tangents, the small tangents that we are drawing at every point should be horizontal. All right, so that's all. So it says identify all the points, or the set of points where the slope is horizontal, and then use that now to make some inference. So now we have our differential equation here. All right. So let's see. We can factorize, do some algebra there, which some of you can do easily, and then find the set of points. So y is equals to 1. So we have y is equals to minus 1, y is equals to 1, and y is equals to 2. So these, you draw these lines. All right, you draw these lines. Let's see. Let's draw those lines. So there we are. We now have dy. We now have dy dx. Oh, something is wrong. So we now have dy dx is equals to y squared minus y minus 2 into 1 minus y squared. So we saw that our Nullclines are now y is equals to minus 1, 1, and 2. So all we do is to come to the graph here, xy, okay, in the plane. So we have y is equals to minus 1, y is equals to 1, y is equals to 2. So that's 2, 1 is 0, minus 1. So all you do now is to draw those lines. So let's draw them. Let's draw these lines. So let's put just the dotted lines. Let's put just the dotted lines. That's y is equals to 2, y is equals to 1, y is equals to minus 1. Those are our Nullclines. Now, the effect of the Nullclines is every solution that is on the Nullcline remains on the Nullcline. Right? So every solution on the Nullcline remains on the Nullcline. Every solution on the Nullcline is remains. So once we start our solution here, it remains on the Nullcline forever. Once we start our solution even here, it remains on that Nullcline forever. It will not move into these other spaces here. But then by finding 3 Nullclines, we are looking at the interval for y. Okay, the interval for y, which is from infinity to minus infinity. So by putting 3 lines there, we have now subdivided it into 1, 2, 3, and 4 sub-intervals. So we have this interval here, and then this interval here, and then this interval here, and then this interval here. In this interval, we know y is less than 1, minus 1. And then here we have minus 1 less than y, less than 1. Then here we have 1 less than y, less than 2. And then here we have y greater than 2. So what we know is solutions inside the same interval, inside one interval, behave the same way. They have the same the sign for the slope, even though the orientation can be different. So they have the same sign for the slope, but the orientation can be different as you move from one point to the other. But it will just be the same sign, the orientation of the same sign. So if it's positive, if it's negative, you are saying it's either going to be closer to the horizontal or something like that, or it will be closer to the what? The vertical. So this is the same sign, but different orientation positions. Okay, so that's all that you need to know. So they behave the same way, but how fast, how steep is the line element? It depends on where you are in that interval. All right. So then, if that is the case, then we can easily say, we can then now say to know, to just have an idea of how steep the of the orientation of the sign of the derivative in each of these. So we need the sign here, the sign here, the sign here, and the sign there. So we just pick representatives. So put y is equals to minus 2. So if you take y is equals to minus 2, so it's as good as just taking some line. It's not an outline. And then at that line, you want to check what is the orientation. So if you put y is equals to minus 2, you will find that your dy dx at y is equals to minus 2 is actually about 36. So 36, so it's steep because you're just saying if you move one step here, you then need to move 36. 36. So you are sort of pointing in that steep direction there. So you will know that this, at this point here, the line elements around this line are very steep. Very steep. So not necessarily very vertical, but very steep, leaning towards the vertical line. Okay, so there we are. But we know here at this line, the Nullcline, we have the slope being what? Being 0. The slope is 0. So we have horizontal orientation. Now, look, as we move from y is equals to minus 2, as we are moving from y is equals to minus 2 to y is equals to minus 1, we start with an almost vertical orientation, but we have to change the orientation so that by the time we hit the Nullcline, we have some horizontal orientation. So it means we have to change the orientation so that I have horizontal by the time we hit that. So you can see that if the direction field will definitely have something like this in that region. Okay, so the direction field, we have those linear elements with almost vertical to and changing the orientation until they are horizontal by the time we reach y is equals to minus 1. So we are done with that one. So we come here between 1 and minus 1. So we choose y is equals to 0. So basically, we are then saying we want to know what is happening along this line here. Y is equals to 0. So if you put y is equal to 0, in there you get minus 2 times 1. So that's so dy dx at y is equals to 0 is actually minus 2. So on that line we have a negative slope of minus 2. So basically you're saying if you move 1, then you are moving minus 2 there down. So it will definitely just lean slightly towards the, so it will lean slightly towards the what? And along this line, these are the orientations, slightly towards the vertical axis. All right. And what would happen now is as we move from 0 to going to y is equals to 0 to y is equals to 1 in this direction here, you can see that we are having a slightly a steep orientation, but as we move, we need to change that orientation because by the time we hit the the nullcline, we need to have a horizontal slope. So we'll just change the orientation slowly and so forth and so forth. So this is the orientation of the direction fields there. So it will change slowly until we get there. Okay, so this is what you will get in the direction field. Now, we know very well that in this region between -1 and 1, we have we also have what? We have a negative slope. And we know that on this nullcline, we're supposed to have an orientation of a 0 slope. So now if you start here, you start your solution here, you then find that you cannot go to that nullcline y is equals to 1 because the slope is negative. So you're most likely going to go this direction there. So you start very close, it's a bit flat, but as you move away and approach the line y is equal to 0, it becomes a bit steep. So you start there and it becomes a bit steep, somewhat flat, steep, somewhat flat, steep, somewhat flat, steep, somewhat flat, steep, a bit flat, steep, a bit flat, steep, a bit flat, steep. Now, so you get this, that's how the between -1 and 1, this is how the solutions will behave. The slopes change orientation from somewhat flat, steep, and then flatten out again. And then let's go in there and put y is equals to 3/2. Yes, so we know now that along the nullclines we have orientation 0, orientation 0, orientation 0. All right, so if you put y is equals 3/2, what are you going to get? If you put y is equals 3/2, you are going to get something like minus, so dy dt dx at y is equals 3/2, you get something like minus 0.31 something 50, I guess, if I remember well. So it's negative, but it's very, very, so you are moving 1 here, but you move just 0 point something, so it's almost flat. So in this region, everything along this line here, it's the orientation is almost flat. It's almost flat. Almost flat. So we have that kind of orientation, almost flat. And it was almost very flat there. almost very flat there, almost very flat there. So it's almost flat everywhere, because by the time you reach the Nullcline, you need to flatten again. So it was almost flat, and then tilt a little bit, almost flat, tilt a little bit, tilt a little bit. Before we know it, it's all flattening again. So those are the line elements in that region. And then if you come here, dy, you can choose y is equals to 3 there. So dy, the x at y is equals to 3 should give you something like 16, which is a bit steep also. So then we come here and now take some or it's closer to 1. It's closer to the vertical axis here. So you now have along that line somewhat steep along the line there, somewhat steep. Down the line there is somewhat steep. But when you move from y is equals to 2 going up, you are almost flat, and then you change your orientation. Almost flat, and then you change your orientation. Almost flat, you change your orientation. Almost flat, 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 change your orientation. Okay, so that's the full direction. So then if you are required to draw the solution curves, so all you know is you have solution curves where you remain on the Nullcline, and then in this case, all these solutions that start here will start very steep, but they will flatten out when they get there. So we have this kind of behavior of solutions. These are the solutions in this region. That's how the solutions behave. In this region, that's how the solutions behave. This region, that's how the solutions behave. Okay. So now, what do we do on the other one? Let me look for another color, and let's take green. Yes. So here you are starting almost flat and goes steep, and then you join there. Starting almost flat, and then you do that almost flat, you then go there almost flat, steep or flat, almost flat, steep, flat, flat, steep, flat, flat, steep, flat, until you hit the Nullcline. So that's how the solutions there would look like. And then of course you know that on the Nullcline, the solutions will just be remain on the line Nullcline. So we go there on the other from between 1 and -2. So what we do, let's look for another color here. Okay, I don't want that one. Let me use yellow. So here you are always coming from flat, almost flat, from flat, almost flat. It's very gentle, but they will definitely. So they're caves that are almost, whose slope is almost 0, like that. I don't think yellow is good enough, but at least you can see something. I'll not use it again. So now all we know is we also have the nullcline here, solutions remain there. And then on the other region, you see there will be steep going away. It will be steep going away from the nullcline, going away from the nullcline, going away from the nullcline, going away from the nullcline. So this is now the full diagram with solution sets, the solution curves. And the question now is, what is the long-term behavior? So that's what you get, you see there. And this is what we're just filling up now, where you just have to put these curves here like that, these curves here like that, these curves here like that, these curves here like that. And of course, on the nullcline, you need to have continuous lines there. And then the other ones, here you have these curves like that, 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 these curves like that. And of course, these ones will be very gentle, sort of very gentle, very gentle, very gentle, but always reaching this nullcline. And these ones will go out, 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 out. All right. Now we want to know the long-term behavior. So imagine we take an initial value in the region y is less than -1. So basically we're saying y naught is defined here. So for example, if we say y naught is equals to -2, so that's a representative initial condition. So all the solutions that are starting at the line y is equals -2 there, at this point y is -2, they will definitely go towards the one, to the on and to this nullcline. And once they hit the nullcline, they remain on the nullcline. They cannot move away from the nullcline. So here you then see that as you continue going, this is the direction where x is approaching infinity. So you can see all of these solutions from here, they basically go towards the nullcline y is equals to -1. So y will definitely approach -1. Now, if you take these ones in here, let's say y of 0 is equal to 0. So if you start here, so you can see all the nullclines here, all the solution curves are going towards the nullcline y is equal to -1. So y approaches -1 again in this one. So when we start our solutions here, so for example, we take y of 0 is equals to 3/2. So if we start right here, then we know we're going to go towards that nullcline. So then it means y will approach the nullcline, y is equals to 1. But if we start here where we have y of 0, for example, is equals to 3, yes, the initial condition. So if we start here, we know that all solutions here are going up. So y then approaches infinity. So this is what we call the long-term behavior of the solutions in this case. All right.